Good morning, student. Today we are going to discuss chapter 2, which is linear time invariant system. By name it shows that linear and time invariant both should be there. So two most important attributes of systems are linearity and time invariance. In this chapter, we develop the fundamental input-output relation of the system, and it is described by convolution operation. So first of all, we have to know about what is convolution and what property of convolution, integral or sum. So in a continuous time system it will be integral, in discrete time system it will be sum. So in this chapter we discuss response of a continuous time LTI system and the convolution integral. Now next one is properties of convolution integral. Third one is properties of continuous LTI system, and after that system described by differential equation. System described by differential equation, then in which condition the system is linear, time invariant, that one I will check. Similarly, in same fashion we can learn the response of discrete time LTI system and the convolution sum. Properties of the convolution sum, after that properties of discrete time LTI system, system described by differential equation. Okay. Now first one is response of a continuous LTI system. So suppose this is a system. This is LTI system is there. Which has one input signal and one output signal. Okay. This LTI system represented by T. So if I am giving input as del T or impulse, then I will get impulse response ht. If any function xt I am giving here as an input, then what will be the output? Okay. So ht is nothing but t into del t. Is that clear? Now response to an arbitrary input. So I am taking arbitrary input xt. So what will be the xt here? Xt will be minus infinity to infinity x of tau del t minus tau d tau. Clear? Now yt is equals to this much. So yt is equals to txt. That one is nothing but t of minus infinity to infinity x of tau. Just put the value of xt here. Is that clear? Now what is t, capital T? X of tau will be there, and t multiply with del now. Since system is time invariant, if system is linear, since system is linear, then yt will be t of xt. But if system is time invariant, since system is time invariant, then h of t minus tau means this ht shifted rightmost to the axis with tau, then that one is equal to what? If I multiply them with tau, then this. So here we have ht is equals to t del t. If in this expression, if this one is 1, suppose, so from 1 since system is time invariant, then if one equation shifted by tau, then we can write like this. Now yt becomes minus infinity to infinity x of tau, and this term we can write h of t minus tau d tau. Any problem? So this equation number 2 indicates that continuous LTI system is completely characterized by its impulse response ht. Okay. Now convolution. If this system is there, suppose this one has xt as an input, ht is response of this system, impulse response of the system, then what will be the yt? Yt will be xt convol with ht. Clear? So convolution integral yt become xt convol with ht, and yt is nothing but it is characterized by impulse response ht. It is shown in equation 2, which is equal to x of tau. If I replace t with tau, then t minus tau d tau. So for any convolution we can express this convolution like this. So this equation is commonly called the convolution integral. This equation, this is known as convolution integral. The output of any continuous LTI system is nothing but the convolution of input with impulse response of the system. So output of any system is nothing but the convolution of input and impulse response. Is that clear? Now in next one we will know about the property of convolution integral. So properties of convolution integral. First property is, if xt input convolve with impulse response, then we can write like this: ht convolve with ht. This is commutative. Convolution integral follow commutative. Next, if xt, suppose two systems are there. So if two systems, two LTI continuous LTI systems is there, then two impulse response h1 and h2. So suppose xt convolve with first h1t and the result will convolve with second h2t, then we can write here the xt convolve with the result of impulse, two system impulse response convolution. This is associative. Next one is distributive. So suppose xt convolve with h1t plus of h2t, then that one will be separately convolved and added it. No problem. This is distributive. Okay. So how convolution integral operation takes place, we have to know. Okay. So operation of convolution integral. I have already told that yt will be nothing but the convolution of input of the system and impulse response of the system, which is equal to minus infinity to infinity x of tau h of t minus tau d tau. Is that clear? Or we can write here, because this one is commutative, so we can write like this. So this is nothing but the h of tau x of t minus tau d tau. So both we can write, no problem. Now in this one, first of all we will find out the time shifted of ht. If ht signals is given, then just shift by tau rightmost and multiply by x tau, and in xt just t replaced by tau and just multiply this, and I will get a signal and integrate from minus infinity to infinity. Is that clear? Now next is properties of continuous time LTI system. Properties of continuous LTI system. So system with or without memory. Since output of memory-less system depends on only the present input. Is that clear? So output of the system this is LTI system is there. So output YT of memory-less system depends on only present input of XT. Causality we have to check. So HT will be 0 for t less than 0. This is the condition for causality. Why? Because t less than 0, HT will be 0. Now in this case YT becomes 0 to t of HT h tau x of t minus tau d tau, or 0 to t x tau h of t minus tau d tau. Is that clear? Now system described by differential equation. So it is represented by differential equation also. So if differential equation in this summation of k is equals to 0 to n ak d to the power k yt by dt k is equals to summation of k is equals to 0 to m bk d to the power k yt by dt k. Okay. Now from this I can write here the a naught yt, because k is equals to 0 here, plus a1 dyt by dt plus dot 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 2 plus an d n nyt by dtn. Clear? Is equals to b naught yt plus b1 dyt by dt plus bm dm of yt by dtn. Now in this system power of each term will be 1, means always linear. If AK and BK is constant, then it says the time invariant. If this is function of t, time, then it will be time variant. Okay. Now power of each term will be 1, so it's always linear. So power of each term is 1, always linear. So if any continuous LTI system is represented in differential equation term, then we can find out if any system represented by differential equation term, then we can say this system is linear time invariant or not. So for linearity, just check the power of each term. If it is 1, then linear, and if it has other than 1, then non-linear. If AK BK, this coefficient, so if AK BK coefficient will be constant, then time invariant. If this is the function of time, then it will be time variant. So we can check if system represented in differential equation form. Okay. Now next is discrete time LTI system and convolution sum. Discrete time LTI system and convolution sum. In same fashion, we can represent a system here, which is LTI system, which has T. Now I am giving del of n. Here I am getting the h of n. If I am giving x of n, then I will get y of n, which is equal to t of x of n. Is that clear? Now in same fashion, just repeat the same slide, but here for discrete time. For any arbitrary sequence, not we can say here the function, sequence. So yn is nothing but the t of xn. And xn will be what? Summation of k is equals to minus infinity to infinity x of k del of n minus k. Okay. Now put the term, and if time invariant, then if shifted by k, then it will be equal. If this is the linear, then this much. Now expression will come look like this. I am not deriving as previous one. I have already derived, so that I am not deriving here for discrete time. Just writing the final expression, which is nothing but the convolution of xn and hn. Okay. Now properties of convolution sum. So same properties, x of n convolve with h of n is equals to h of n convolve with x of n. This is commutative property. Associative property, x of n convolve with h1 of n is totally convolve with, suppose, h2 of n is equals to x of n convolve with h1n convolve with h2 of n. This is associative property. Now next one is x of n convolve with h1 of n plus h2 of n so we can write here the x1n xn convolve with h1 of n plus xn convolve with h2 of n. This is distributive property. Now properties of discrete time LTI system. is same. Now system described by differential equation. If system described by differential equation, this much. So first of all we have to know the properties, which is equals to sum of k is equals to minus infinity to infinity mod of hk should be less than infinity. So this is for a stability. Now next is if system is represented in differential equation, means k is equals to 0 to n, suppose ak y of n minus k, and on right hand side its a summation is from 0 to m bk y of n minus k. So the condition for linear time invariant is same. So power of y of n minus k and x of n minus k should be 1. Then linear. If ak and bk is constant, then time invariant. If it depends on or it is a function of time, then time variant. Okay, so these are the things which we have derived or we have discussed in LTI system. Now we will go for some example and we will discuss those example and understand properly LTI system. So this is the overview of LTI system, which one we have to remember, and just focus on theory. After that there are so many problems available or exercise available regarding this chapter, so kindly focus it on and we will discuss it later. Thank you.